Hi guys, I'm out today and tomorrow, so I wanted to talk to you about this worksheet you're going to get and show you a walkthrough example. As I was doing this, I realized that maybe I didn't leave you enough space on your paper to work these out. So you're going to need another sheet of paper to work these out, and then I want you to record your answers on the worksheet that I've given you. All right, so this is what the worksheet looks like. We're going to work through number 1 together. Okay, so part A, use the vertex and direction of the opening to decide how many real zeros there are. Okay, so when you look at y equals 4 times x plus 3 squared minus 7, you should know by now that the vertex is, say it, -3 and -7. We should also know that the direction of this opening is up. The reason that the direction of the opening is up is because the A value, or that 4, is positive. Okay, so what I've done is just quickly sketch a vertex of -3, -7, and my opening is up. Okay, I didn't really worry about steepness here. I just wanted to get it good enough for me to be able to answer the question, how many real zeros does this equation have? Okay, now how we can tell the zeros. Remember the zeros, if you look back or look up at your directions, it reminds you that what I mean by zeros are roots, x-intercepts. So if you're looking at this graph, I want you to think for a second, how many x-intercepts are there for this graph? When you're looking at this, if you're saying this graph does not cross the x-axis, there are no x-intercepts, I see where you're coming from. I see that it's not crossing. But remember what these arrows mean. These arrows mean that the curve will continue up and out forever. So even though the picture I have drawn does not show that the curve has crossed, it shows that it will cross. Okay, so I just extended that out. Again, this is just a rough sketch. I did not ask you to graph it well. What does need to be graphed well is the vertex. That has to be in the right quadrant. If it's in the wrong quadrant, you're going to get the wrong answer. And then the direction of the opening must be correct. If you do those two things correctly, then you're going to be able to answer part A correctly. Okay, so there should be 2 real zeros because of the vertex and the direction of the opening. Let's go on to part B. Okay, I promised today that this worksheet would be mostly review, and it is. Okay, Algebra 1 review. So convert each function into standard form. This is what standard form is, remember. This should look very familiar to you from Algebra 1. You didn't deal with vertex form in Algebra 1. You dealt more in standard form. So we have to go back there to connect some pieces from Algebra 1 to Algebra 2 over the next couple days. All right, so convert each function into standard form. You must follow order of operations. Okay, and I've written that again right here to remind you. We're going to expand the right side of the equation using order of operations. Now, for order of operations, you might be thinking, please excuse my dear Aunt Sally. You know by now that I am not a fan of that. Instead, I like to think of it as gems, grouping, exponents, multiplication, subtraction. Now, wherever there's multiplication, division also is included. And wherever there's subtraction, addition is included. Okay, so if we're going to expand the right side, the first thing we think about is the grouping. And if we look up here, what's grouped is the x plus 3. Now, what grouping really means is that you can add the x and the 3 together. But we know that we cannot because those are not like terms. So grouping, there's nothing for us to do as far as grouping goes. What we will do first is the exponent part. Okay, the x plus 3 squared. That's going to be the first thing that we tackle. Okay, so when we do x plus 3 squared, it's important that you remember that it's not just x squared plus 3 squared. Instead, it's x plus 3 times x plus 3. And to multiply this out, we will have to use, say it. If you said distribution, you were right. If you said FOIL, you were right. Either way, when you multiply that, you're going to get to x squared plus 6x plus 9. Okay? Make sure you do the F, the O, the I, and the L of the FOIL, or that you distribute x to both of those and 3 to both of those and combine your like terms. All right, so we've done the exponents. Now I'm going to rewrite the equation with the new part in there. So y equals, we still have the 4 times, but the expanded form of x plus 3 squared, and then the minus 7 on the end. Okay, so that's the exponent part of order of operations. Now let's go to the multiply divide part. Okay, so for the multiply divide part, we look at this and it's 4 times, so we're going to do that. And then the last is the subtraction. Okay, so addition, subtraction. That just basically means we're going to combine our like terms. So the like terms would be the 36 and the negative 7, and that's going to give us 4x squared plus 24x plus 29. Okay, I told you only to write the answers on the worksheet that I gave you. For part A, what I would want to see is the quick sketch and saying 2 real zeros, kind of showing where those would be according to your sketch. We'll tweak that in a little bit. And then part B, I would like to see this that I have boxed in. You need to have the supporting work to turn in with your paper. The next part, part C, now after doing parts A and B, use the quadratic formula to find the roots. I may get cut off in between this as 4th period starts, so I might be pausing this in the middle and picking back up later. Just an FYI, if it feels a little weird for a second. All right, so quadratic formula is a method to find the roots or the zeros of a quadratic equation. Okay, it's a quadratic equation in standard form. So you can't use the vertex form with quadratic formula. You have to use the standard form, which is what we just found in part B and you have on your screen here. So remember quadratic formula, x equals negative b. Okay, pop goes the weasel. I think you sang that if you had Mrs. Wilson last year for geometry. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay. Pop goes the weasel. There are other songs that you can find on the internet that may, I don't know, stick in your head. I know there are some rap versions. Anyway, you can look those up if Pop Goes the Weasel's not your thing. The important thing is that you can remember it. What I always do before I complete a quadratic formula problem, really any problem with a big giant formula, is I will set up a skeleton, a framework for the formula before I begin. Okay, so I'm showing it here to you blank, but what I do on my paper is I put it in the blank form, and then I start filling numbers into the blank, and that's what we're going to do on the next page. Notice the negative is still here, the plus minus, the square root, the square, the minus, the 4, and the all over 2. Those things stay the same. It's the A, the B, and the C that will vary from problem to problem. All right, so 1 hour later, I feel like SpongeBob right now. We're going to finish up this 1C. Okay, so you have this worksheet. You're going to be doing 1 through 10. We've already done parts A and B. I'm finishing up part C now. I guess that was more for me than for you. Anyway, using the quadratic formula to find the roots. From the quadratic formula, we need to know the A, the B, and the C value. So remember, it's ax squared plus bx plus c. Make sure when you're looking at your equation that these are in the order of A, x squared, b, x, and then c. C is always your constant. So even if this 29 had been written in the middle or up here, if it doesn't have an x with it, that is your c. The b is what is with x to the first, and the a is what is with x squared. So normally they're written in order, but in case they're not, make sure you're looking for that. All right, so let's go ahead and fill in the a, the b, and the c. Okay, so this is just the first step for quadratic formula. After we've made the skeleton, now we're going to fill in the numbers for a, b, and c. And then we're going to start to simplify. I absolutely do not want you to plug this all in your calculator and press enter. It is not a good idea. Instead, what we're going to do, I'm going to show you what to put in first, what I'm comfortable with you just inputting in your calculator, and what I want you to take a couple steps for. So I'm going to highlight this under the radical. That, for quadratic formula, is called the discriminant. The discriminant is what we take the square root of in quadratic formula. You'll hear me call it the b squared minus 4ac next week. Okay, so I want you to use your calculator to find the value of the discriminant. You can also write down the value of the denominator in the next step. You shouldn't need a calculator to do that. All right, so take a second, write down the value, or write down the next step, and then come back and take a look at what I have. So you might need to pause. Okay, so here is our quadratic formula with the simplified discriminant, negative 24 plus minus the square root of 112 all over 8. All right, now what you guys are going to do while I'm gone is find approximate solutions. That means that you're going to use the calculator to get an approximate decimal value of our answers. Okay, so how do we use the calculator to do that? I want you to do it in 2 steps. Okay, so to find the first root, you're going to do the numerator first, negative 24 plus the square root of 112. And you have this decimal. I've written it rounded to the thousandth place, but you need to leave that long on your calculator until you are totally finished with this part of the problem. So the screen says negative 13.417, but my calculator has a much longer decimal than that. After you get that, then divide by 8. And that will give you your first root, negative 1.677. The second root comes from the minus part of your quadratic formula. So negative 24 minus the square root of 112, get that decimal by pressing enter, and then divide by 8, okay, to get your second root. All right. I want you then to go back to your sketch that you made in Part A and make sure that these roots are reasonable. Okay, do they look like they could be? So let's go back there. Here, remember, was our original equation that we graphed. Here is our standard form. I'm going to be reminding you next week about how to graph from standard form. Here are the roots we just found. Remember, we thought there should be 2, so this should make sense that we have 2. So the black is the original drawing. Looks like a smiley face, doesn't it? And then the red is me putting the roots in. So our roots were negative 1.677. So between negative 1 and 2 should really be a little closer to negative 2. And negative 4.323. So between negative 4 and negative 5, a little closer to negative 4. Okay? No, my roots weren't going to go through those perfectly because I didn't pay attention to the 4 as far as how wide. I just made it cup up. But as you can see, if we draw in the axis of symmetry through the vertex, then these roots are balanced on both sides. So that should make us feel good about the roots that we've found. As you go through today, you're going to be looking at sometimes you're just going to get a single root. Sometimes you're not going to get any roots at all. And that's what question 10 is going to ask you to bring back together. Okay? We'll talk about those things on Monday. Also, just continuing on, I'm going to talk to you about exact solutions from the quadratic formula, reminding you how to do that. We're going to relook at exact solutions from the vertex form and how we can get these answers without converting into standard form. I'm going to talk to you about graphing from standard form and how you find the axis of symmetry even from the quadratic formula. So we have a lot to do on Monday and throughout next week. I need you to make sure that you get 1 through 10 done Thursday and Friday, preferably in class.